Now let us consider the third application of UCM, that is called as banking of roads. Another point, angle of banking. This is the most important article of the chapter rotational dynamics. Number of times it is asked in HSC board exam for 3 to 4 marks. So let us consider that what do we understand by the term banking of roads. In the figure, this yellow shaded is represented as a vehicle. In the figure, the yellow shade portion, it represents as a vehicle. Okay. In the figure, a vehicle is moving. A vehicle is moving on the surface of the road. What is shown in the diagram in the figure, a vehicle is moving on the surface of the road. Then at the turn or at the curve, it is kept inclined. At the turn or at the curve, it is kept inclined to the horizontal surface, due to which the upper edge of the road is at upper level than the inner. What we are observing here in the figure, whenever a vehicle is moving on the surface of the road, then at the turn or at the curve, it is kept inclined to the horizontal surface, due to which upper surface of the road is at upper level than the inner. It is called as banking of roads. Okay, so second point, what do we understand by the term angle of banking? We see that here theta, it is the angle called as angle of banking. This angle is made by the surface of road with the horizontal surface. What do we understand by angle of banking? Angle made by surface of road with the horizontal surface, it is called as angle of banking. Sometimes we have the section 1, section A in HSC board, 1 mark article. Sometimes only the definition, what is banking of road. Sometimes only the definition, what is angle of banking. Then at that time we have to write. So let us consider the definition of banking of road, that whenever a vehicle is moving on the surface of road, whenever a vehicle is moving on the surface of the road, then at the turn, see in the diagram, this is the vehicle, it is moving. Okay, it is moving on the surface of the road. At the turn or at the curve, it is kept inclined to the horizontal surface. It is kept inclined to the horizontal surface. Okay, see here, at the turn, at the curve, it is kept inclined to the horizontal surface, due to which, or because of which upper edge of the road is at upper level than the inner, called as, it is called as banking of roads. It is called as banking of roads. Next point, what do we understand by the term angle of banking? In the figure, theta be the angle. Okay, what is angle of banking? Angle made by the surface of road. Angle made by the surface of road. Yes, which roads are making the angle. We have two roads, one is surface of road, another is horizontal surface. Both these roads are making the angle. That angle is called as angle of banking. What is angle of banking? Angle made by surface of road with the horizontal surface, with the horizontal surface, it is called as, yes, it is called as angle of banking. Okay, so see first these two definitions, that what do we understand by banking of road and what is angle of banking. Watch it. Now let us see the derivation of banking of roads. We know that in the figure, the vehicle is moving on the surface of the road. Okay, in the figure, a vehicle is moving on the surface of road. A vehicle is moving on the surface of road with the n. In the figure, we have the factor n is here. With the n, this n acts like normal reaction. With the n as a normal reaction. Okay, and it is resolved. It is resolved into two components. All these things we are observing in the diagram, in the figure, and with the normal reaction, it is resolved, it is divided, it is dispersed, it constitutes, it is splitted into two components. It is splitted into two components. The first one is called as n sine theta. N sine theta. Okay, the first component is called as n sine theta. Okay, it is horizontal. N sine theta, it is horizontal, which provides necessary centripetal force. What do we understand by the term n sine theta? N sine theta is the component. It is horizontal. Okay, and it provides necessary centripetal force. Whereas the second component, that is called as n cos theta. Okay, see here, the second component, it is n cos theta. Okay, it is vertical, that we are observing also in the diagram. The component n cos theta, it is vertical, useful for balancing the weight. Okay, it is useful for balancing the weight. Full stop. Mathematically, both these points can be written as follows. Mathematically, we can write, yes, mathematically we can write, that is n sine theta, it is useful for necessary centripetal force, that is mv square by r. Equation number 1. The second component n cos theta. What the second component n cos theta? It is useful for balancing the weight, that is mg. Equation number 2. Dividing equation 1 by 2. Dividing equation 1 by 2, comma, we get, yes, what we get, that is n sine theta upon n cos theta is equal to mv square upon r into mg. So which factor we can cancel here? The component here, the factor n, it gets cancelled. Here it also gets cancelled. So what we get? Sine theta by cos theta, that is nothing but tan theta, is equal, what remains there? V square upon rg. Okay, this is the general expression for, okay, this is This is the general expression for banking of roads. Okay, this is the general expression for banking of roads. Watch it carefully. What we have seen: n sin theta mv square by r, n cos theta balance with the weight mg, dividing 1 by 2, n cancel, sin theta by cos theta, tan theta, cancel, v square by rg. Okay, wait, this is the expression for banking of roads. Okay, or it can also be written as, that is theta is equal to, when this tan goes to that side, it becomes tan inverse v square upon rg. Okay, and this is the required expression. This is the required expression for angle of banking. Okay, this is the required expression for angle of banking. If we take cross product here, nothing is there, 1. Taking cross product, what we get? Or we get v square is equal to rg tan theta. When we take the cross product, we get v square is equal to rg tan theta on square root. On square root, we get v is equal to under root rg tan theta. Okay, this is the general expression for, maximum safety speed. This is the general expression for maximum safety speed. So first of all, watch it, all these things. Now let us see its remaining part, that we know that the vehicle is moving on the surface of the road. Obviously, if force of friction between the wheels of the vehicle and the surface of the road takes place, that force of friction is represented by the factor Fs. We have denoted in the figure Fs. It is the force of friction, where the friction takes place when the vehicle is moving on the surface of the road. Then at that time, the wheels of the vehicle and the surface of the road, in between them a friction generates. That friction is called as limiting force of friction. Okay, and that limiting force of friction, it is also resolved into two components. One is Fs sin theta, another is Fs cos theta. Likewise, the component n, that is nothing but the normal, and that normal is resolved into two components, that is n sin theta and n cos theta. Let us see that how we can write the component or the factor n acts as a normal. The factor n, it acts as a normal. Okay, having n sin theta, okay, provides centripetal force. Therefore, we can write that is n sin theta, that is centripetal force mv square by r is equal to, related to n sin theta, see in the diagram, n sin theta minus static friction, that is Fs cos theta. Equation number 1, the very first point, that is the component n, it is resolved into two components. N sin theta acts like horizontal component, it is useful for centripetal force. So mv square by r is equal to, with respect to friction, n sin theta minus Fs cos theta. Equation 1. Likewise, another factor we have, that is called as n cos theta. Okay, it is useful for balancing the weight, that is mg is equal to, okay, another component, that is n cos theta, it is useful for balancing the weight, that is mg is equal to, with respect to force of friction, we can write n cos theta plus another factor we have Fs sin theta. fs sine theta, equation number 2. Okay, dividing 1 by 2, dividing equation 1 by 2, what we get, that is mv square upon r into mg is equal to the right side n sine theta minus fs cos theta divided by n cos theta plus fs sine theta. Which factor cancels here? The factor gets cancelled. What we get? That is v square upon rg is equal to v square upon rg is equal to the right side n sine theta minus fs cos theta to the denominator. Watch it carefully. N cos theta plus fs sine theta. Okay, now dividing by cos theta, dividing by cos theta to RHS. What we are doing here, dividing by cos theta to RHS, what we get? We get that is v square upon rg is equal to, watch it carefully, n sine theta divided by cos theta minus fs cos theta divided by cos theta. Okay, see here the thick line, that is the original thick line, divided by what remains here, n cos theta divided by cos theta plus fs sine theta divided by cos theta. So watch it carefully. What we can do here, v square by rg as it is, n factor as it is. We are well familiar that sin theta by cos theta, that is nothing but tan theta, minus here this cos theta factor gets cancelled. What remains there? There is here only fs, the thick line, divided by here also cos theta, this factor gets cancelled. What remains here? N plus fs as it is. Once again, sin theta by cos theta, that is nothing but tan theta. Okay, we are well familiar that according to the definition of friction, what is static friction here? The limiting force of static friction is the ratio of, it is the ratio of force of friction to normal reaction. What do we understand by coefficient of static friction? It is the ratio of limiting force of friction to normal reaction. That is mu s is equal to fs upon n. This is the definition of coefficient of static friction. Nothing is there. One, taking cross product, what we can write? That is fs is equal to mu s into n. In short, we get the value of fs. So wherever fs is there, we can put the value mu s n. So what it becomes? It becomes that is v square upon rg is equal to n tan theta as it is minus, what is fs? Fs is nothing but mu s into n, this thick line divided by as it is n to the denominator as it is plus at the center as it is. What is this fs? Once again, fs is nothing but mu s into n, mu s into n. What remains? Also tan theta is there. Yes, v square by rg as it is. What we can take common here? We can take n factor common. What remains in the bracket? Tan theta minus mu s. Again, the thick line divided by n factor gets common. What remains there? Nothing is there. 1 plus this n is common. What remains? Mu s tan theta. So which factor again gets cancelled? This n gets cancelled. Okay, what we get finally, that is v square upon rg is equal to, that is tan theta minus mu s divided by 1 plus mu s tan theta. Okay, or or we can write, or v is equal to, v square is there, we are taking square root and rg goes to that bracket, rg goes to multiply to this bracket, that is v is equal to rg. Okay, v is equal to, we can write it in this way, that is rg in the bracket, that is tan theta minus mu s divided by 1 plus mu s tan theta, 1 plus mu s tan theta. Okay, so this is the required expression for maximum speed of a vehicle. Watch it.